Welcome back. In this video, we're going to be doing section 4.7, which is about linear inequalities in two variables. And so in short, what this is about is we saw for a single variable how it is to make the jump from saying something like 2x is less than 6, or sorry, 2x equals 6. So this gives us a single number as a solution, x equals 3. And then we saw inequalities. 2x is less than 6, meaning that x is less than 3. Instead of having a single number for a solution, we saw that there was an interval of numbers that made up solutions. And now, recently, we've seen how to look at equations x plus y equals 3, that would have a line for a graph. How would it be if we change this equal sign into an inequality sign like less or greater? And we're going to see that it's a similar sort of a jump in how the graph looks and how we represent our answers. So basically, the equations of lines that we have had, y equals mx plus b, and so on, we're just going to change the equal sign into either less, greater, less than or equal, or greater than or equal, and explore the solutions of those inequalities. So let's start by taking a look at this inequality. Y is greater than x minus 3, and decide if each of these points, 4, 9, and 5, 4, makes a solution to one of these inequalities, to this inequality. So here, y is greater than x minus 3. I'm going to do 4, 9 first. We'll replace the y by a 9 and the x by a 4. And so we get 9 is greater than 1, and that's true. Okay, so that means that 4, 9 is a solution of this inequality. Okay, for 5, 4, we'll put 4 in for the y. And then for x, that will be 5 minus 3. 4 is greater than 2. That looks like yes. Okay, so it looks like both points are solutions. Let's see if we can make one up where it isn't. We need to make it so that y is not bigger than x minus 3. So how about if we had a y of 0 and an x of 7? I just made that up. So y of 0 greater than, and then 7 minus 3, 0 greater than 4. That's no. So there's going to be infinitely many pairs in the xy plane. Some will be solutions and some won't. And so our goal in this section is to figure out how to draw a picture of those solutions. When we switch to inequalities in one variable, from 2x equals 6 to 2x less than 6, we had to learn how to do interval notation. There isn't really an interval notation for this section. Our answers in section 4.7 are basically just going to be the graphs. Okay, and so we want to see how to do those graphs now. Basically, how this is done is we're going to graph the corresponding equation. Let's do a fresh one, actually. Okay, we're going to look at y is less than or equal to a half x minus 4. So for this, we'll want to graph the corresponding equation. Y equals a half of an x minus 4. So we've had some practice with that. So our y-intercept is at negative 4. Our slope, write this down, our y-intercept was at 0, negative 4, and then our slope is a half. So from here, sorry about that, Zoom crashed again. So we'd found the y-intercept for y equals a half of an x minus 4. We'd found the y-intercept was negative 4, the slope was a half, and so I put onto the graph the point 0, negative 4, and then the slope I went up 1 and right 2 to get a second point on the line. Okay, so that was graphing a line, and so how to finish this, it turns out that when you're graphing one of these inequalities in two variables, that all of the solutions form a region, and they're all going to be on one side of the line or the other. And so we need to decide now if the points that make up solutions are going to be above or below this line. And so what we'll do is we'll test a point in the inequality. So we'll test a point. It doesn't matter what point you test as long as it's on one side of the line or the other, not actually on the line itself. Most often, if I can, I like to test the origin. Why? Because the coordinates are 0 and 0 is easy to plug into things. Okay. I'm going to use 0, 0 when I can. Okay, just because it's easiest. And so 0 is less than or equal to a half of 0 minus 4. So we need to know if that's true or not. 0 is less than or equal to 0 minus 4. 0 is less than or equal to negative 4. And that's either true or false. Is 0 smaller than negative 4? The answer is no. So that's not true. So that means that the origin is not a solution to our inequality. Since it's not a solution, none of the points on that side of the line are solutions. So all the points on the other side make up solutions. And how we usually show that is by using some shading on the correct side of the line. Okay, and that's basically all there is to it. As I'd said, there's no separate kind of interval notation that we use for this. Basically, we use shading to show where the solutions are. Okay, so to recap the steps, you graph the corresponding line. And one thing that we hadn't addressed now is what do you do if it's strictly less? If it's a less than or equal to or greater than or equal to, when you draw the line, use a solid line. If it's less or greater, use a dashed line. As you recall, when you're doing an inequality in one variable, you may have seen if it's like 2x is less than 10, so that x is less than 5, you might represent that with a hollow circle, where if it was 2x is less than or equal to 10, you would represent that with a solid circle to differentiate whether or not the 5 belongs to the solution set or not. When it's a linear inequation in two variables, a linear inequality in two variables, use either a solid or dashed line to indicate whether the points on this line are solutions or not. Step 2, you test a point on one side or the other. If that point's a solution, shade that side, otherwise shade the other side. Okay, so that's it for the instruction. There's not a lot to it. We just need to try some examples. Okay, we're going to graph x minus 4y is greater than 8. So the corresponding equation is x minus 4y equals 8. And this one is kind of in general form, so I'm going to use the intercepts to draw it. When x is 0, y will be negative 2. When y is 0, x will be 8. So 8, 0, and 0, negative 2 are on the graph. This one was a greater, not a greater or equal. So I'll be drawing a dashed line for this. That way everyone will know that the line itself doesn't make part of the solution set. Then I'm going to test a point not on the line. I'm going to test the origin because, again, 0 is easy to work with. 0 minus 4 times 0 is greater than 8. 0 is greater than 8. No. The origin fails. So that means that the solutions are not on the origin side. They're on the other side. So we'll shade below the line. Okay, here is one for you to try. We're going to graph the solutions to y is less than or equal to negative 3x. Let's actually make that greater than or equal to, just because y is greater than or equal to negative 3x. So take a minute, pause the video, try this yourself, then restart the video and see how you did. Okay, our corresponding equation is y equals negative 3x. This one is a little different because it passes through the origin. So our y-intercept is 0. And so then we'll use the slope to get another point on the graph. I'm going to go down 3 and right 1. Because this one has the or equal to in it, I'll be drawing a solid line for this. Since this one passes through the origin, I can't use the origin as a test point. I know the origin is a solution, but it doesn't help me decide whether I should be shading the left or right side of this line. So we're going to test some other point. It doesn't matter which side you pick. I'm going to go with 2, 0. Okay, I just chose it. Okay, there was no special reason for that. I'm going to put 0 for y. So 0 is greater than or equal to negative 3 times 2. I put 2 for x and 0 for y. 0 is greater than or equal to negative 6. That's yes. Okay, so that means that the points on the right side of the line all make solutions. And so we're going to shade the whole right side. Everything on the right side makes up a solution. Okay, let's try that again. Here, y is less than 3. Our corresponding equation is y equals 3. Okay, y equals 3, that's a horizontal line, right? So here, it should be y less than 3. I was supposed to use a dashed line here. So let me be more careful and slow down a little bit. Okay, the corresponding line is y equals 3, but because it said less than, not less than or equal, I need to use a dashed line. Then I'm going to test the origin. Okay, put 0 in for y. There's no place to put the x, and that's fine. 0 is less than 3. Yes. So that means that all the points below the line make up solutions. All those points have a y-coordinate less than 3. Okay, x is greater than or equal to negative 2. X equals negative 2. That's a vertical line that passes through negative 2. And then again, I have to decide whether we should shade on the right or left of that line. I'm going to test the origin. So 0 for x. Is 0 greater than or equal to negative 2? There, the answer is yes. So we'll be shading that side of the line. So all the points to the right side of that line make up solutions. Okay, that's it. That takes us to the end of this section. It was a rather short one. We saw that it was just a couple of steps. Graph the corresponding line. And if it's strictly less or greater, use a dashed line. If there's an or equal to, use a solid line. Check a point on one side of the line or the other. And if it passes the test, the solutions are on that test point side, otherwise they're on the other side. There's still like interval notation way to write the answer for this that we'll see. So the answers on these are just the picture. Okay, that takes us to the end. Let me know if you have any questions, and then have a great day.